Hello, everyone, and welcome to our webinar. Our topic today is how to specify engineered wood products. My name is Karen Beebe, and I'm the Western Region Manager for APA's Field Services Division, and I'll serve as the moderator for today's session. APA is a nonprofit trade association representing manufacturers of a variety of common structural engineered woods. In addition to quality verification and product testing, APA conducts research to improve engineered wood products and the systems where they are used. We also educate users and specifiers on the product's intended use and potential applications. Before we start today's webinar, I need to cover some housekeeping details. To ensure that everyone can hear the webinar clearly, we've muted all participants. And while we're bookending the discussion with our cameras on, we will be turning those off during the balance of the session in order to maximize the slide size on your screen. Our class today is approved for both AIA and ICC continuing education credits, and a certificate will be provided to use for AIA, ICC, or other organizations that self-report continuing education. Your feedback is important to us. I'd like to point out that you see a QR code on your screen. If you open up your smartphone and point it at the screen, it'll take you to a link for the survey for this session. We'll show you this link a few more times during the course today. Our presenter today is Warren Hamrick. Warren is an engineered wood specialist for APA, serving the southeastern United States. Warren conducts workshops and consults with designers, code officials, and other building professionals on the best practices for the specification, selection, and application of engineered wood products. Warren graduated from North Carolina State University with a Bachelor of Science in Civil Engineering. And prior to joining APA, Warren worked as a project manager for a structural engineering firm, which specialized in commercial construction. For those of you just joining us, welcome to APA's webinar on the topic of how to specify engineered wood products. I'll now turn the microphone over to our speaker, Warren Hamrick.
All right, thank you, Karen. And thanks again for everyone that's participating in today's webinar. All right, so let's get started. On the screen, you're gonna see a copy of the course description, and you were provided this when you registered. So what we want to do today is to help understand the structural implications of your design and help in collaboration between the architect, engineer, and builder. So today what we're going to do, we're going to begin with an introduction to engineered wood products, and we're going to have some specification tips. We're then going to move on to mass timber, and finally we're going to finish with some fire discussion. So starting with our learning objectives that we're going to cover today, we're going to identify the basic types of engineered wood products and talk a little bit about their properties. And we want to talk about the material characteristics of these various types of engineered wood products that are commonly available for use, and they're mainly going to be used as either panel or beam products. And we want to recognize the aspects of engineered wood products and how that contributes to the constructability. And then talk about the proper design and specification of wood structural panels, structural composite lumber, cross-laminated timber, and glulam beams. So, I mean, we can begin by asking kind of an obvious question for this topic. So what is engineered wood? So engineered wood is any wood-based building material that's been improved physically by a man-made process. So to kind of simplify that, what we like to say is engineered wood basically takes smaller harvested trees. We take out the natural characteristics, so these are things like knots, pitch pockets, scars, etc. And then we cut the logs into pieces, which then are glued back together. And what that ends up doing is making a stronger and bigger wood product than the tree we started with. So what are the actual engineered wood products? As I mentioned in the description, generally speaking, engineered wood products can be divided into two categories. We're going to talk about panel products and framing products. This slide lists the most common types of panel products. And you'll hear us talk about wood structural panels, and that's because that's the terminology used in the code. And for your information, both plywood and OSB are wood structural panels. Over the years, EWP panel products have also expanded to include siding and more specialized products that we'll also talk about. So beginning with our framing products, these can be used for a variety of applications. So in general, your wood I-joists are typically going to be used as floor joists and roof rafters. Then we have a group of other engineered wood products that are classified as structural composite lumber, or SCL. And these SCL products are going to include parallel strand lumber, or PSL, and that's typically going to be used as a beam. You also have laminated veneer lumber, or LVL. That's used often as beams, but can sometimes be used as joists or rim boards, and it could occasionally be used as a stud replacement. Laminated strand lumber, or LSL, that's going to be used for headers, rim boards, stair stringers, and studs. And OSL, which is commonly going to be used as a stud replacement, possibly as a rim board or a stair stringer. We also are going to talk about glue laminated timber. Glulam is typically going to be used as either a beam or a column. Now, cross-laminated timber, or CLT, it can actually be considered in both the framing and panel categories. Cross-laminated timber is made from sawn lumber pieces, which are stacked on top of each other. Now, unlike glulam beams, the orientation of the wood grain changes throughout the depth. And, just like plywood or OSB, CLT panels do have a strong axis span direction. You're typically going to see CLT used for roofs, floors, and walls. CLT is currently code approved for gravity framing. Using CLT for lateral load resistance is going to typically require the engineer to use the alternate means route provided in the IBC code, or the recently added 2021 SPIDWIZ sections 4.5 and 4.6. You'll also sometimes see engineers use other materials on top of CLT, and this can be like using OSB or plywood, and this is to get the roof or floor diaphragm capacity that they need. So there are four main reasons designers and builders typically turn to engineered wood. First is sustainability. So engineered wood products can be manufactured from small dimension lumber, as well as utilize many species of wood, which makes these products really resource efficient. And by strategically placing wood fibers where they're most needed, these products maximize the use and strength of the wood material. Second is predictability. Engineered wood products are very predictable, and this applies both in dimensions and performance. This because they're designed and manufactured to maximize the natural strength and stiffness of the wood using durable and moisture-resistant adhesive. Consistent dimensions they're typically going to be a big advantage for contractors because they don't need to make continuous adjustments for warped or crowned pieces of sawn lumber. Engineered wood products are produced dry to a consistent moisture content, which helps minimize differential shrinking. Engineered wood products are manufactured to meet internationally recognized standards with consistent design values supported by continuous quality control with third-party oversight. The third advantage is performance. So on top of the dimensional stability and predictability, engineered wood is typically available in longer lengths than dimensional lumber. Now this is going to result in fewer pieces to purchase and install. And because we're disassembling the tree and we're going to remove some of the normal imperfections and then reassemble the parts, engineered wood products can outperform sawn lumber in strength and deflection. And fourth is waste reduction. So the ability to have long lengths and pre-cut framing packages is also going to result in less waste, which impacts the amount of material going to the landfills. And for the contractor, this could also result in reduced disposal costs. When using conventional framing lumber, as much as 10% of primary framing members are rejected due to excessive cupping, splitting, warping, etc. So now let's discuss some characteristics about the different engineered wood products. And we're going to begin by looking at the panel products. This slide is showing some characteristics that OSB and plywood share. Some people don't realize that OSB has layers just like plywood. But unlike plywood, the wood grain in any one layer is more randomized. This slightly more random orientation gives OSB panels a slight edge when it comes to stiffness in plane. Both OSB and plywood undergo structural tests in both their wet and dry conditions. And in the United States, they must comply with product standards. And U.S. building codes require that structural panels for application in the United States comply with either PS1 or PS2 voluntary product standards. And these are developed under procedures published by the U.S. Department of Commerce. PS1 establishes requirements for structural plywood and is primarily a prescriptive standard. PS2 establishes requirements for structural wood-based panels. So this includes both OSB and plywood. APA siding is available with a wide variety of patterns and finishes. All of the adhesives used in the siding are moisture resistant with an exterior bond classification, and the panels are designed to be impact resistant for wind-blown debris. One of the most popular specialty products which is used in sunshine areas is radiant barrier sheathing. Radiant barrier sheathing is basically a wood structural panel with a reflective coating on one side. And these are used in the attic of a lot of residential structures to improve the energy performance. Sheathing can also be used for concrete formwork. Now, realistically, you could use any exterior grade panel for the formwork, but many manufacturers now produce specialty panels with pre-applied quick release coatings. There are also panels which are manufactured with overlays, and they're going to provide an improved concrete finish as well as increasing the lifespan of the panel. The overlay panels commonly used in concrete forming are high density overlaid and medium density overlaid. These are commonly referred to as HDO and MDO. These overlays are bonded to the plywood under high heat and pressure in a press. Industrial panels and overlay panels are also manufactured similar to basic plywood or OSB, with slight adjustments tailoring them to their specific end use. And these industrial end uses, they could be something like shipping crates or cabinetry. So now moving on to talk about framing products. So we're going to discuss wood I-joists, the family of structural composite lumber, and glulam. So structural composite lumber, or SCL, is going to include laminated veneer lumber, LVL, parallel strand lumber, PSL, laminated strand lumber, LSL, and oriented strand lumber, or OSL. This is a family of engineered wood products which are created by layering dried and graded wood veneers, strands, or flakes with moisture-resistant adhesive into blocks of materials known as billets. These billets are then resewn into specified sizes. Wood I-joists and other engineered wood products make optimum use of the natural resources by putting the high-strength wood only where it's most needed. This efficient use of the wood fiber creates a joist that not only contains 36% less wood than dimension lumber 2x10s and 2x12s, but it's also going to be stiffer and stronger. Another advantage of the wood I-joist is the flange width. So the flange width is often going to be wider than nominal lumber. So what this will do is provide a larger target for fasteners to hit when you're sheathing floors or roofs with wood structural panels. Another advantage to the wider flange also means the sheathing can be spanning less between the joists. I-joists are typically manufactured in 4 common depths, which are 9.5 inch, 11 7/8 inch, 14 and 16 inches. Now, while these are the common depths, some manufacturers may also produce other depths. All APA I-joists meet the PRI 400 performance standard at a minimum. You'll see many I-joist manufacturers are going to make products that exceed the PRI 400 minimums, and they're going to have proprietary APA product reports or ICC ES/ESR reports. So when specifying I-joists, it's common to check with the manufacturers for specific engineering properties, and it's also important to check on product availability. The products listed here can all be used in the rim application. So all of the products listed can have APA stamps, but APA rim board is made from OSB. And it's important to remember to use all engineered wood products in the floor system because we recommend never mixing sawn lumber with engineered wood products. Now, the reason we recommend this is due to shrinkage and dimensional differences that can occur. Engineered wood floor systems offer value in many ways to the builder. So this photo is showing a wood I-joist floor system, which is enclosed with an OSB rim board. Wood I-joists create a flat floor or roof system with all the components exactly the same depth. I-joists are consistent in size, straightness, strength, and moisture content, which provides consistent performance within a floor, which that's going to equate to flatter and quieter floor systems. The I-joists and subfloor, when properly glued and fastened together, help eliminate the independent movement of the floor system components. And that independent movement is what creates noises like squeaks and also uneven floor surfaces. Positive connections of these components are going to result in reduced callbacks. And that's not only a headache for the builder, but it ultimately impacts the profitability of the project. APA does recommend both glue and fasteners to attach the floor sheathing to the floor joists. I-joists are often paired with laminated veneer lumber or LVL beams and headers. Nationwide, laminated veneer lumber is the most widely used type of structural composite lumber. It uses specially selected ultrasonically graded veneers and orients all of the veneers with the grain running lengthwise. These veneers are lap jointed to create long lengths. Aligning the grain parallel to the span in this way maximizes the bending and axial strength while minimizing shrinkage. Laminated veneer lumber, or LVL, beams are commonly made in depths which match the depths of I-joists. Deeper LVL dimensions are also available. The most common thickness is 1.75 inches, but LVL is available in thicknesses up to 7 inches. And they're commonly available in 1.5E, 1.8E, and 2.0E in bending stiffness or modulus of elasticity. The modulus of elasticity measures the object's ability to resist being deformed. So the higher the modulus of elasticity, the better to resist deflection. So here are two slightly less common members of the structural composite lumber family. Laminated strand lumber uses strands with a ratio of around 150 times their thickness. These products are commonly going to be used for rim boards, wall studs, and headers. Oriented strand lumber is very similar but uses shorter strands, and these strands are about 75 times their thickness. The common application of oriented strand lumber is for a wall stud replacement and stair stringers. LSL and OSL are manufactured in I-joist compatible depths. Their common thicknesses are 1.25 inches, 1.5 inches, 1.75 inches, and 3.5 inches. Their common stiffness values or modulus of elasticity are 1.3E and 1.5E. Now you'll note these are not quite as stiff as the laminated veneer lumber that we discussed on the previous slide. As always, check with manufacturers for additional information on structural characteristics and availability. Another framing product is glue laminated timber, or glulam. So glulam uses layers of 1.5 and 1 3/8 lumber that are going to be bonded together in a flat stack. The wood grain runs parallel to the length of the beam. Glulam has this in common with the other structural composite lumber products that we discussed. So like the I-joists, glulam beams typically stick the higher strength material at the high stress areas, which are the top and bottom laminations. They can also be used for beams, headers, studs, and in some multifamily applications as rim board. Glulam can also be used as a column. Now in the column application, the laminations are generally going to have the same strength characteristic throughout the layup. Glulam are also available in I-joist compatible depths and in the common thicknesses of 3.5, 5.5, and 6 3/4. Now you'll notice that these thicknesses will flush out with 2x4 and 2x6 studs. As with the other engineered wood products, they are readily available in lengths up to 48 feet. Their common structural designation is a strength of 2,400 pounds per square inch, or PSI, in bending, and a stiffness or modulus of elasticity of 1.8 E. Glulam can be custom made with just about any shape or length. So that gives them a really unique advantage if you're working with a more complex geometry. So now let's take a look at a relatively new product, cross-laminated timber. So cross-laminated timber, or CLT, is a versatile product that in many ways can be considered a wide beam or a panel with strength in two directions, where they can be used as a structural member for floors, roofs, and walls. Cross-laminated timber is a large-scale prefabricated solid engineered wood panel. A CLT panel consists of several layers of kiln-dried lumber boards stacked in alternating directions, and they're going to be bonded with structural adhesives and then pressed to form a solid, straight, rectangular panel. Board thicknesses typically vary between 5/8 of an inch to 2 inches, with board widths ranging from 2.4 to 9.5 inches. CLT panels consist of an odd number of layers, that's usually going to be 3 to 7 layers, and may be sanded or pre-finished before shipping. While at the mill, the CLT panels are going to be cut to size, and this is going to include door and window openings. These are cut with state-of-the-art CNC routers, and they're capable of making complex cuts with really high precision. Finished CLT panels are going to be exceptionally stiff, strong, and stable, handling load transfer on all sides. The panels can be manufactured at custom dimensions, but it's always important to check with each manufacturer, as transportation restrictions might dictate their length. So looking at some of the CLT basics and benefits, CLT is lightweight yet very strong. It's going to have superior acoustic, fire, seismic, and thermal performance. CLT is also fast and easy to install, and it should generate almost no waste on site. CLT offers design flexibility and low environmental impacts. And for these reasons, cross-laminated timber is proving to be a highly advantageous alternative to conventional materials like concrete, masonry, or steel, especially in multifamily and commercial construction. There's also the aesthetic and biophilia effect of exposed CLT panels in mass timber structures. Engineered wood products that bear the APA trademark are manufactured in accordance with APA or national standards. The trademark is the manufacturer's assurance that the product conforms to the standards noted on that trademark. APA members commit to a rigorous program of quality inspection and testing. Many engineered wood products are proprietary and use proprietary engineering standards reports and APA product reports for their code recognition and for the product use and design information. So now that we've introduced the various commonly used engineered wood products, Let's shift slightly our focus to proper specification. So on this slide is a very helpful APA specification resource. This is our engineered wood construction guide, which is form E30. And this is probably the most popular single resource for all engineered wood products. And here's an example of the panel specification guide from the engineered wood construction guide. So let's take a look at what needs to be called out for panels and a little bit about why that needs to be called out. So on the left, you're going to see an out-of-date specification. So looking at our FYIs on this slide, we mentioned earlier, it's best to call out wood structural panel instead of plywood or OSB. Wood structural panel is going to include both plywood and OSB. When you're looking at the thickness, calling it out as panel performance category rather than the exact decimal thickness is a best practice. And then CDX is a term that is commonly used, but it's actually a very limiting specification. That would limit you only to plywood with a C face and a D back. So here's the best way to specify wood structural panels, and here's an example of how to write that out. So we've got 15 32nd category, APA rated sheathing, 32/16, that's the span rating, exposure 1, nominal 4 foot by 8 foot, tongue and groove or square edge. And again, remember to avoid using the acronym CDX and avoid using the exact decimal thickness definition. Now, this is an example of the difference in the trademarks between an exposure 1 and an exterior bond classification. Exposure 1 panels will be appropriate for applications that will be covered with finished materials. Exterior bond classification is used when the panel is going to be permanently exposed. So concrete form panels and siding are two examples of exterior grade panels. Now we're going to review that one more time because this is one of the most frequent questions we get. So again, exterior bond classification panels are suitable for applications subject to long-term exposure to weather or moisture. Panels classified as exposure 1 are intended to resist the effects of moisture only during construction. And a couple other things that you could consider adding to your specifications, making sure you have an 1/8 inch gap on all panel edges. So panels, when they come from the manufacturer, they're going to be really dry. As they acclimate to the environment, they're going to tend to expand. And having that 1/8 inch gap is going to allow the panels to expand without having to deal with things like wall buckling. It's also important to have fasteners 3/8 of an inch from panel edges. And then if you're interested in referencing some wet weather installation tips, you could refer to a couple of APA publications shown on the slide. So APA trademarks are the manufacturer's assurance that the product conforms to manufacturing and product performance standards that are shown on the trademark. The mark appears only on products manufactured by APA members, which are committed to APA's program of quality inspection and testing. And the trademark should reflect what's specified in the plans. So moving to glulam. Here's an example of a glulam specification from the E30 and an example trademark. When specifying glulam beams, let's review the glulam nomenclature and what's important to specify. So let's look at what glulam combination symbols are and how they're reflected in the glulam trademark. The glulam trademark identifies the allowable stress of the material, the appearance classification, how the plies are graded, which is either going to be visual or mechanical, the stress combination number, and the wood species. So, you know, that's a lot of information, which leads to the question, what's important to specify on a glulam? So we would emphasize that while many stress classes are listed in codes, that you focus on the common beam combinations shown here as they're the most commonly stopped material. And it's always a reminder of a good practice to discuss availability with your local supplier. So taking a closer look at the APA glulam grade stamp or trademark, we see that it contains several critical pieces of information you should know if you're specifying beams. So what does this label tell us? First, it tells us the allowable bending stress is 24F, which is noted as which represents 2400 FB. The V tells us that the plies in this glulam were visually graded. If they were mechanically graded, this would be noted by an E. I like to think of the number 4 as the recipe for how the plies in the beam are laid up. So this number tells the manufacturer how to make the beam, but it doesn't really communicate a lot of information to the designer or the installer. The trademark will also tell us the appearance grade, if the beam is balanced or unbalanced, the wood species, if the beam is cambered, and the mill number, which is going to identify the manufacturing mill. Suppliers can assist their customers in understanding the information on a grade stamp. Also, you can refer to APA's glulam product guide for more information on glulam specifications. So moving on to structural composite lumber, here's an example of an LVL trademark and the structural composite lumber specification from the Engineered Wood Construction Guide, Form E30. So remember that these manufacturers will often have their own specifications that you should use. And also remember that the structural composite lumber section is going to include LVL, LSL, OSL, and PSL. So taking a look at I-joists, and here's an example of the I-joist specification from the E30, as well as an example trademark. With I-joists, some manufacturers use APA performance standards and others are going to have their own standards. And with I-joists and other proprietary products, some designers are going to create a table giving acceptable options or minimum engineering values to make product selection easier. So finally, we'll move into mass timber and cross-laminated timber, to be specific. So there are basic grades covered by the ANSI APA PRG 320 and custom grades provided by APA product reports. The example shown on the right comes from our Form E30. For more specification information, here's a picture of an example of an APA product report. So these reports indicate that the product meets the intention of the building code when used as identified in the report. The product reports identify the specific design uses and limitations, as well as the design properties. These reports are available for free download on the APA website at apawood.org. Many of APA's member manufacturers have also developed green verification reports. These reports help building officials and design professionals determine a product's eligibility for points under recognized green building standards. And you can find these reports on the APA website or the manufacturer's website. And sometimes the manufacturers might have their own green report. So moving along to our next session, or our next section for today, let's take a look at the relatively new kid on the block, mass timber. So mass timber gets a lot of attention wherever we go in the field. We have developers, designers, code officials, all wanting to know more about mass timber. Woodworks has reported that as of September 2022, there were over 1,500 mass timber products that have been constructed or were in design phase, and these include all 50 states. The major benefits of mass timber construction is warm, aesthetically pleasing, environmentally responsible means of construction that can be used in multifamily, multi-story, in both commercial and single family applications. And this is going to allow for faster installation and better carbon sequestration than cold form steel or concrete construction. The 2021 International Building Code expanded the type of constructions from 9 to 12, and they did this by adding 3 new construction types within the Type 4 heavy timber classification. The new types are Type 4A, 4B, and 4C, and they're going to allow mass timber structures up to 18 stories and 270 feet. Each of these Type 4 building classes have different maximum heights and stories, along with different protection and fire rating requirements. So kind of going back, what exactly is mass timber? So we often hear the term, and when we hear it, the focus seems to shift to a discussion or comment that mass timber is cross-laminated timber. So, we wanted to clarify that misconception and emphasize that this is not exactly correct. Mass timber is a broad term that addresses construction that utilizes products that come in many forms. Now, this does include cross-laminated timber, but it also includes some newer products like mass plywood panels, veneer laminated timber, and more traditional heavy timber like glue laminated timber. Mass timber can include glulam decking as well as traditional post and beam framing. Also gaining some traction is nail laminated timber and dowel laminated timber. They're designed in accordance with the American Wood Council's National Design and Specification for Wood Construction. I would mention that APA members produce all of the products required for mass timber that we've talked about, except for nailed or dowel laminated timber. And I'd also remind that many of the products like LVL, LSL, and the panel products, plywood and OSB, can be used as complementary products in mass timber construction. So let's take a closer look at our mass timber products, and we're going to start with cross-laminated timber. So CLT is a large-scale, prefabricated, solid engineered wood panel. This panel is going to consist of several layers of dried lumber boards stacked in alternating directions, bonded with structural adhesives, and pressed to form a solid, straight, rectangular panel. Now, while at the mill, the CLT panels are going to be cut to size, and as we mentioned before, this can be done with CNC routers. And while this pre-cutting of openings saves a lot of time with installation, it does mean that penetration coordination early on in a project is extra important. The panels can be manufactured at custom dimensions, and you should check with each manufacturer in order to optimize your bay sizes. Dimensional limitations are going to vary by manufacturing facilities and their transportation methods. And I would mention that CLT is not a commodity product. So that typically requires early coordination with a specific CLT manufacturer. Cross-laminated timber has a great strength to weight ratio and also has superior acoustic, fire, seismic, and thermal performance. And this is in addition to being fast and easy to install. For these reasons, we're seeing CLT is proving to be a highly advantageous alternative to conventional materials like concrete, masonry, or steel, especially in multifamily and commercial construction. And let's don't forget the advantages of the aesthetic and biophilic effects. Taking a look at the picture on the right side of this slide, this is showing a CLT panel on the left side of the photo and a mass ply panel on the right. Mass ply product features and benefits are much the same as CLT shown on an earlier slide, and the mass ply products can be used in a similar applications as CLT. Now you'll remember that CLT consists of several layers of lumber boards stacked in alternating directions, bonded with structural adhesives and pressed. So mass ply products are made a little bit differently. They're composed of multiple layers of veneers that have been glued and pressed in a variety of combinations and orientations to produce a panel or beam product. Glue laminated decking is an addition to the classical glulam beam product line. It's basically a uniform grade glulam beam installed on edge and glued together to form the panel. So there's no extra certification requirements for this glue laminated decking. These members are stressed primarily in axial tension and compression, just like a wide beam. So when glulam is used as decking, the properties for bending around the y-axis can be used for design. These panels can be considered a competitor with nail laminated timber. As I mentioned earlier, APA has a wealth of publications available on our website, and this includes case studies that feature mass timber projects. One example is the Marshall Elementary School in Vancouver, Washington, that utilized glulam beams and columns and a CLT roof deck. And this is shown in the picture on the left. We also have featured a project spotlight in our Designer Circle newsletter. This project, which is the picture on the right, is the Portland International Airport Terminal B. This product utilized mass ply panels and glulam in a mass timber roof. So finally, if you want more information, you can visit our apawood.org website and select the product tab located in the upper left of the screen. Select the product you're looking for more information on. So for this example, we selected CLT, and this will take you to a page that has general information about the selected product. And this is also going to include a list of APA manufacturers, product reports, green certification reports, as well as other information about the product. So now let's move on to our last section of the day. Interest in using engineered wood products in Type 3 construction has been rising in recent years. Type 3 construction is the type of construction in which the exterior walls are constructed of non-combustible materials. The interior building elements are of any material permitted by code. All other building elements must have a 1-hour fire resistance rating. And these requirements do present some challenges to using wood in Type 3 construction. But we'll show with some planning, these challenges can often be addressed. So to help us understand fire construction, let's review some phraseology and definitions, as sometimes the confusion starts with knowing and using the right terms. So let's start with the term fireproof. All buildings have flammable contents and furnishings, so there's really no such thing as a truly fireproof building. If these contents were to catch fire, they can quickly generate enough smoke and heat to cause extensive damage. So while fireproof is probably not attainable, fire-resistant construction is well within reach. Extensive testing of building components and systems has resulted in certified fire-rated assemblies that retain the structural ability to contain a fire long enough for the inhabitants to escape. Now, since we know there's no such thing as fireproof, let's look at what applies to fire-resistant construction. And let's start with the fire-rated assembly. This is an assembly constructed with a list of prescriptive materials that include lumber, plywood, gypsum, etc., that measure the length of time that the assembly can continue to perform its function when exposed to fire. This is determined through testing the assembly using a standardized fire exposure. And this is normally going to be expressed as a blank hour fire resistant rated assembly. Now, fire retardant treated wood refers to wood products that have been pressure impregnated with a fire retardant chemical. So what this does is inhibits the flame spread across the surface of the wood, which may qualify for a reduced fire hazard classification, but does not necessarily impact the fire rating. A fire rated assembly applies to the products used in testing that assembly. Now keep in mind that having a fire rated treated product does not equate to having a fire-rated assembly. So this takes us to the last point that I'd like to address, and that's products treated with non-pressure impregnated process does not translate to being a fire retardant treated wood. Section 2302.2 of the IBC also requires that ASTM E84 or UL 723 test shall be continued for a 20-minute period and not progress more than 10 feet. Section 2303.2.2 says the use of paints, coatings, stains of other surface treatment are not an approved method of protection. And as I mentioned on the previous slide, the International Building Code, or IBC, lists fire-rated assembly requirements for Type 3 construction in Table 601, which is shown here. So for our talk today, for Type 3A construction, let's focus on the bearing wall assembly requirements of 2 hours for exterior walls and 1 hour for interior walls, as well as the floor construction associated secondary structural members requirement of 1 hour. So let's start with the floor ceiling 1 hour assembly. In Type 3 construction, using engineered lumber, and when we're using engineered lumber, we're talking about wood I-joist in this case. That's a popular choice. An I-joist system is more versatile than open web floor trusses in that they're, as well as more versatile than solid sawn lumber. They're going to be more dimensionally stable. It can be trimmed on site, and they're available in long lengths and deep depths, which are going to allow the floor or ceilings to be designed with fewer pieces. They also allow for holes to be cut through the wood I-joist, allowing for the installation of mechanical systems. They're going to be quick to install and weigh less than dimension lumber and plated trusses, require less draft stopping than plated trusses, and are supported by APA quality certifications and manufacturer's warranties. The 1 hour floor ceiling requirements for engineered lumber or I-joist systems can be found in APA's Fire Rated Systems publication, which is Form W305, and that's available on apawood.org. These publications detail many rated assemblies for I-joists. So let's first take a look at what's been historically our most popular rated system, which is shown here in figure 5.5. So this system has been popular in that it allows the use of I-joists from 9 1/4 to 24 inches in depth, and these can be spaced up to 24 inches on center. They can have a flange thickness of 1.5 inches deep with an area of at least 2 1/4 square inches. Now in this rated assembly, 2 layers of 1/2 inch Type C gypsum is installed on the underside of the joist to act as a protective layer. So this has sometimes been noted as a disadvantage of an I-joist system, as dimension lumber and plated truss systems may be constructed with 1 layer of gypsum. So to address this perceived disadvantage, APA, along with its members, recently tested a single layer 3/4 inch Type X gypsum system, and this was found to achieve the 1 hour rated assembly requirements. So this can be used where 1 hour rated assemblies are required in Type 3 construction. This system is shown in our APA Fire Rated Systems publication, again that's Form W305, and is shown here in figure 5.9. We believe this system offers a reasonable alternative to the double layer system and more easily allows for the use of I-joists along with its advantages in Type 3 construction. Now, I would advise that prior to specifying this assembly, you check for the availability of 3/4 inch Type X gypsum for your particular market. So now let's turn our attention to the wall assemblies, and particularly where the floor ceiling assembly intersects a rated wall assembly. This is often a point of confusion or debate. So looking at IBC Table 601, we recall that the exterior wall needs to have a 2 hour rating, and IBC Section 602.3 lists the requirements for Type 3 construction being a type of construction in which the exterior walls are non-combustible materials. Fire retardant treated wood framing and sheathing shall be permitted within the exterior wall assemblies of a 2-hour rating or less. Now, one question that comes up is the rim part of the wall assembly or the floor assembly? So typically rated wall assemblies don't detail the rim as part of their assembly. I'm not going to get into the details of the multiple wall assemblies available, but note that APA Fire Rated Systems publication provides several options. One approach that's promoted in the American Wood Council DCA 3 is that in platform construction, the rim is considered part of the floor assembly, not part of the exterior wall assembly, and therefore not required to be fire-resistant treated wood. However, they do acknowledge that the portion of the floor that transfers the load from the wall above to the wall below must be designed to provide continuity of the fire-resistant rated walls from above to below. So this means the blocking shown in this detail must be designed to support the full wall load if the wall is required to be rated from the exterior per IBC 705.5. This detail allows for FRT sheathing, studs, and wall plate with untreated rim and blocking designed to carry the load. And again, it's always important to check first with your local jurisdiction for approval on this. So APA has a technical topic, TT124, approach to the use of untreated glulam as a rim. So when wood is exposed to fire, the char layer protects the remaining unburned wood against heat. Under fire exposure up to 2 hours, the char depth of a glulam can be calculated, and the residual cross-section after a 1 or 2 hour fire exposure can still carry a significant uniform vertical load. In construction where the rim board is required to be 1 or 2 hour fire rated, unprotected glulam rim boards can achieve the intended fire rating and can safely carry the design load. So this technical topic provides an easy to use table. It lists an allowable uniform load and what size glulam member is needed for the 1 or 2 hour fire exposure duration from one side. Some designers specify and use FRT treated glulam or LVL rim for type 3 buildings. These products could be used in rim applications that we discussed, but could also be used as headers within the exterior load-bearing wall. So to address this opportunity, APA and the USDA Forest Products Laboratory worked to develop ASTM standards for the evaluation of FRT glulam. So fire retardant treated wood framing is permitted within exterior wall assemblies of a 2 hour rating or less. And recently APA published a technical topic summarizing the results of this pilot test program, examining the structural properties of FRT glulam. And we did find that the structural design properties were affected by the actual treatment on the glulam. So be sure to evaluate the product with the design capacity reductions and recommendations, which should be obtained from the wood treating company, as the reductions can be very significant, as was demonstrated by this testing. Additionally, I'll note the test of FRT LVL is currently in progress. So if you get a request for FRT LVL, you should handle it the same way you would handle FRT glulam, and recognize that the reductions should be provided by the specific treater. And it's also important to remember the LVL does not qualify as heavy timber. So bringing this section to a close, I'd like to reinforce some of the main messages associated with FRT glulam that you should keep in mind. You want to make sure you take the design reductions when specifying FRT glulam. And again, you check with the treater for the specific design value reductions for their specific product. APA's posture on this, when we communicate about FRT glulam or FRT LVL, we just seek to educate that this is an option that may be available for type 3 building design. we don't encourage or discourage use of the products. We just encourage designers get the information they need when approaching this design. So chemical treatments are going to differ, and this is why designers need to get the technical information from the treater. We only tested one proprietary treatment, and our technical topic actually showed a roughly 50% overall reduction. So in this case, a 24F glulam essentially becomes or performs like a 12F glulam. Now, our testing was also limited and only covered the modulus of rupture and the modulus of elasticity. We did not test for compression, shear, fastener performance, etc. And we still promote that glulam is heavy timber, even in type 3 construction. All right, to kind of wrap up our session today before we take some questions, brings us back to our course description. So just to review today, we began with an introduction to engineered wood products, as well as some specification tips. We then talked about, what is mass timber and what products constitute mass timber, as well as some complementary products that can be used in your mass timber projects. And then finally, we just wrapped up with some discussion on fire. So that concludes what I'm going to cover today. Again, thanks so much for your attention and participation. And at this time, I believe Karen has been monitoring questions.
Yeah, thank you, Warren. Excellent presentation. And you'll notice that the QR code has reappeared. So please, if you haven't already, take this opportunity to go to the link for the survey, give us some quick feedback on your thoughts on the session, so that'll help us improve this program and others that we offer at APA. So we only have a couple minutes left. There are a variety of different questions that have come in. I think you just ended on this topic, but I'm just going to start with it since it's such a brand new subject. And it just said, can you give me a little more information on, as a designer, how to specify for FRT treated beams about the strength reduction?
Yeah, they probably came in before we finished covering that section. It's pretty basic. It's because these treatments are proprietary. They're not all the same. While we did perform testing, which showed about a 50% strength reduction, that was only on one particular product. So the key takeaway, there's two things that are key. One is you're likely going to have a strength reduction, but to find out exactly what that is, you need to consult with the actual treatment manufacturer. Yeah, I think that's good to reiterate. Doesn't hurt to say that multiple times. And then another very common question we get at APA, and it came in today, was, basically they're used to specifying CDX, and why do we discourage that? Yeah, so CDX is a common construction term, but if you specify CDX and you get material that actually meets the specification, you're going to be limited. A lot of people use CDX when they just mean sheathing. They just mean wall sheathing. They may not even mean plywood or OSB specifically. They're just used to using the term CDX. But if you specify that, what that actually means is you're limited to a plywood panel, so no OSB, and you're limited to a C face and a D back, because that's what you specified. The other reason that we discourage that is the X on the end of CDX. Some people think that means it's an exterior bond classification, and it's not. A CD panel is going to be an exposure 1 bond classification. Yeah, thank you, Warren. And your design firm, if you were like a lot of companies, you might just be passing along the old structural notes or the specifications from project to project. So it's a good opportunity to check and freshen those up. One last question, just to, again, touch on the other topic that, is new for APA to be covering today, was you talked a bit about the new mass timber construction types, and where can I get more information on this information? Yeah, so, obviously APA is going to have information, so feel free to reach out to us for that. But a couple of other organizations that are very helpful along these topics is AWC, the American Wood Council. I know they do a lot with code development, and I know they have a webinar that covers the new 2021 changes. So they would be a good resource. Another excellent resource on mass timber is Woodworks. They have a ton of information. They do a lot of training like we do with a more heavy focus on mass timber. So I would say look for American Wood Council and Woodworks for more information.
Thanks, Warren. And as always, questions continue to come in as we're doing our Q&A, but we are over time, so I'm going to have to stop the Q&A and thank you for the questions that you submitted. If we didn't get to yours, we'll be passing those to your local field staff representative, and they'll be contacting you soon to get back to you. And before we conclude today, I want to touch on a few last reminders for this session. If you aren't already signed up to receive our APA update newsletter, I would highly recommend you do so you'll be informed of future webinars as well as updates to our publications and standards. How you do so is that from our homepage, you're going to click on sign in the upper right hand corner of the page, and then a drop down menu will come down and you'll just sign in, select that registration and decide what you want to receive from APA. In this case, it would be the APA update newsletter. And we have field staff located throughout the country. These talented individuals like Warren are available to assist design professionals, code officials, builders on all things engineered wood. Their individual contact information can be found on our APA website, apawood.org. Please reach out and take advantage of this free resource. And then lastly, don't forget to download your AIA or ICC certificate of completion. And with that, I'd like to thank you all for attending. Have a great day.